What propels light? Why is light always moving? Light is always moving because everything is always moving or would be, if it had its way. The default speed of the universe is the speed of light. If there's nothing to slow you down, there you are, bopping around at sea. So, why are you not moving at the speed of light? Well, it's because of your interaction with other stuff. If you have a particle that interacts with something called the Higgs field, it has mass. This mass has a lot of cool properties. Being able to touch it is a very popular one, but another is that it requires more energy to get you moving. That makes sense, right? You need to push a dump truck a lot harder to get it moving than you need to push a bike. Heavier things require more energy to move faster. If you have any mass, though, it's impossible to get enough energy in you to get you to the speed of light. You'd need an infinite amount. And that's just not going to happen. The only things that can move at that speed are things that are already going at that speed, and that don't have any interaction with the Higgs field at all. A photon is a massless particle. It doesn't interact in a meaningful way with the Higgs field in a vacuum. At least, which is what gives mass-having particles their mass. So there's nothing to slow it down. It just runs at its own speed, which is the speed that everything in the universe would run if it didn't have anything getting in the way. Wow, surprised face. So anything that is traveling slower than the speed of light has mass? As far as I can tell. And in a vacuum? Yes. Things that don't have mass, and aren't interacting with other things that have mass, move at a constant rate. If I'm wrong about this, I'd love to hear about it. But from what I can gather, I'm not a physicist. Just a nerd that seems to be the case. Does a photon emitted by an energized atom of matter instantly leave at the speed of light, effectively instantly accelerating? Was it always at sea from birth? Or is there a near instantaneous ramp up of the photon to speed? It's always at sea. The process of acceleration is instantaneous. Or, more precisely, photons have no reference frame. They have no perspective. They don't accelerate, but simply exist at sea. Think of light like Goku. Goku wears weighted clothes. Those clothes give him mass. When he takes off the clothes, he goes faster. Light is the same way. But it took off every bit of mass, which makes it move at the fastest possible speed. So the speed of light isn't just the speed of light, but the fastest anything can possibly move in the universe without breaking fundamental physical laws. The reason we will never reach the speed of light is because we have mass. So what you're saying is light is naked? Nah. He's not saying anything, he's super sci on it. It helps if you think of light less like a stone that's been thrown and more like a ripple through water. So the sun and other light sources are just making ripples all the time. And the thing they're making ripples in is usually just the vacuum of space. There's nothing there. So there's nothing to slow down the ripple or make it bounce around. It just goes and goes until it hits something. Something like our atmosphere. So light hits our atmosphere, and it bends a little. So the sky looks blue because more blue light bends than other colors. Maybe the light hits you and bounces off. The place where you blocked the light is now a shadow. And the light that bounced off of you lets other people see you. No light, nothing to see. Lots of light, easy to see. Some things also absorb light. They just soak up the energy. That can make them warm, like how the sun heats up the sidewalk. Or it can turn into energy to grow. Like how plants use sunlight. A combination of bounced light and absorbed light is what makes everything you see. That absorbed light could also be called stopped light. The energy is gone, and the ripple vanishes. I'm going to steal this explanation for myself. This is such a great analogy. Not only does it subtly convey the whole electromagnetic wave/particle situation, but also intuitively makes sense of some phenomena like light instantly accelerating to see as soon as it appears. How it slows down when not in a vacuum and stuff like diffraction or generating interference patterns. Thank you so much. I'm quite flattered. More importantly, when a photon flies into your mouth, are you eating it? Only if you swallow. From a photon's perspective, there is no sense of motion. Because there is no time, as your experience of time relative to the rest of the universe slows as you approach the speed of light. So, traveling at the speed of light, the photon exists at all points simultaneously with no sense of past, present, or future. When approaching the speed of light, distances shrink. So you say that the photon is at all points along its path. I presume. But really it's already at its destination as soon as it's emitted. No. It's amazing. From the perspective of a photon that got emitted from the sun, it took no time to reach Earth. But from our perspective, the same photon took 8 minutes to reach here. Both are true and both are real. That's unbelievable. It's a fallout of how electromagnetism works. A changing electric field causes a magnetic field. A changing magnetic field causes an electric field. Given that light is wiggling electric and magnetic fields, it can't not move. It's like asking why a water wave is always moving. You can't stop a wave. It's not stable in one position because it's a dynamic phenomenon that's driven by its own change. It's only stable if it moves. Another way of phrasing this thought is that a wave isn't a thing but rather a propagation through a thing or many things. An ocean wave travels by propagating through many water molecules. That's kind of moving towards the discredited luminiferous ether model of light. Though, light doesn't propagate through a medium. To tack onto this, if light doesn't experience time, unless absorbed or slowed by a medium, does that mean there are still photons out there emitted from the Big Bang? The premises are wrong. To say that light experiences or doesn't experience time presumes it has a perspective. It would require traveling at the speed of light. But that means light speed is zero in that perspective, which contradicts relativity, which says light speed is always 299692458 m/s. So it doesn't make sense to talk about whether light experiences time or not. But that has no bearing on whether there are photons out there emitted by the Big Bang. Whether there are photons emitted by the Big Bang is a coherent question regardless of whether they experience time or not. Or even if the question of their experience is nonsensical. It turns out we don't. Because it was too hot and dense back then. Right before light started traveling freely. Photons had high enough energies to remove electrons from atoms. And they can't travel far without hitting one. Before that, it was so hot that atomic nuclei experienced the same thing. And before that it was even hotter. You might as well ask what is light at the same time. It doesn't really have a propulsive force. Once emitted, it moves at the speed it does unless slowed down by a medium. But once the medium's gone, it goes back to its normal speed. Kinda like a wave in that sense. But it also has momentum and other things that make it seem like a particle, but you can't have a particle just passing through solid objects indefinitely. Light is weird stuff that we don't really understand why, we just understand that it is the way it is. But does a photon really slow down? Or does it just take a bit longer to reach its destination because it's being absorbed and re-emitted by electrons it collides into? As far as I know, a photon always travels at the same speed. It's like if you were always driving at 100 km/h, but had to take a lot of detours. It took you 2 hours to go 100 kilometers. Even though you were at a constant speed. I took up to Physics 3 in college, touching on relatively a bit, and found it difficult to get conceptualize. But thinking about it this way blows my mind. If we were on Earth and could somehow watch a live video feed of a person on a spaceship traveling at 0.5 c, would their actions appear to us to be moving at half speed also? What happens when a photon moving at the speed of light impacts a surface? I know that it will either be absorbed or reflected, but what is physically happening when the photon is absorbed and converted to heat? These questions are incredible. Something about physics and the mechanics of the universe is just fascinating. Remember, you're not the first and will not be the last to ponder the universe. Many great minds have sought answers in all forms, but the truest and most pure answer is, what matters most is not the destination but the journey. Enjoy yourself. Make up your own answers to satisfy your curiousness. And then find something that brings you peace and love for what little time we have with this level of consciousness. It's a blessing in disguise. Even the pain and suffering we feel is still a blessing on the grand scale of existence. Light is an electromagnetic wave i.e. It is made up of an electric field, like around a wire with an electric current in it, and a magnetic field, like around a magnet with a magnet in it. When an electric field collapses, it generates a magnetic field, and when a magnetic field collapses, it generates an electric field. So a photon, or light, is a self-propelling electromagnetic field that oscillates between an electric field and a magnetic field. Einstein calculated how fast such a field would travel and calculated the speed of light. Don't misattribute the Maxwell equation to Einstein. He didn't come up with them, just realized wider implications. Watch Vsauce's video What is the Speed of Dark? That will help you go further down the rabbit hole. Highly recommend this one too. Mind-blowing. This is just me as a layperson trying to figure it out a bit myself. But it seems that a photon begins traveling in the first place because it is emitted from some source, and does so with nothing to stop it until it is absorbed somewhere by its interaction with other particles. Traveling with its full value of c in the spatial rather than temporal, it experiences no time, and also has no mass. So perhaps even when reflected off of an object, it never loses its energy until absorbed. Again, I'm not a physicist, but I love to learn about it, try to visualize it. Note that it does have momentum as well as energy, and can transfer those to something it interacts with, completely or partially. But yes, with no interactions, it just keeps going. Dave. Some photons have traveled so far about 13.6 billion light years. The energy that produces light is what propels it, in the same way that the energy exerted in hitting a gong contributes in propelling sound waves. So, a few things. 1. Light is a wave. It is the protection of every in spacetime as electromagnetic radiation. You cannot really stop a wave. We say it is like a partial because an interaction with light is nearly instantaneous and contains energy. 2. Light is technically not always moving, and we even have the ability to stop light in certain materials. Light is always traveling at c. We can cause it to appear to move slower with certain mediums, but the light is never not moving at c. During a lecture on human anatomy, a student asked me, do SS push the farts out, or do farts push the S out, with a completely straight face? So, couldn't read all the comments. This reminded me of a conversation I had with my dad while I was in college. Both of us engineers, and in trying to make solar winds more than an abstract concept. Wrong question. The right question is, why doesn't everything move at the speed of causality, i.e., speed of light? Answer: mass is just energy that is bound up and can't move at its natural speed. Question: if tachyons exist, could the reason we have no evidence of them be because traveling faster than the speed of light would mean that such an existence be nigh observable in the first place? You don't need any propellant to keep moving. You only need it to change your velocity. This is called Newton's first law. Light has completely different property, and Newton's law won't hold well in quantum mechanics. The first Newton's law is universal. Notice the question was much more basic than it looks. It doesn't depend on any difference between light and particles with non-zero rest mass. Instead, it merely asks how can light always be moving without being propelled? And the answer is, you don't need any propellant to move, only to change your velocity. Because it is made so at the time of its creation. Light, electromagnetic radiation, is essentially an electric field and a magnetic field. The important thing is that a change in magnetic field can result in the creation of electric field at a nearby spot, and a change in electric field can result in the creation of magnetic field at a nearby spot. These are expressed very beautifully in the Maxwell's equations. So, when in some part of the universe an electron quivers, it results in change in electric field, which results in a change in electric field and generation of magnetic field in the next spot. Then this pair of electric field and magnetic field changes replicate themselves in the next spot, and so on. The speed of light is calculated from the laws which govern these self-replication. In fact, it is not the most funny thing about it. The most funny thing about it is that this replication process takes place independent of the speed of the observer. Imagine a person moving with a speed of c/2 wrt another person. They both will see the exact same process. The distance between the next spots and time taken is governed by Newton's law and Maxwell's equations, and so speed of the observer doesn't even come into picture. As a result, the light will move at same speed with respect to both of them. The experts seem to be saying light moves because it does. That's the default state. Well, I guess in the end, if you go all the way to the beginning, it's the Big Bang that set light particles in motion. Like all energy, everything travels at the speed of light. If you are traveling 100% in space, you are traveling 0% in time. If you are traveling 100% in time, you are traveling 0% in space. Everything else is somewhere in between. Okay. Help me out here. If I run an electric current through a tungsten wire, things happen. A photon hits my eye seemingly instantly. How does that photon accelerate to C as it spits out of the tungsten wire? Does it accelerate first or just takes off at C? I think only things with mass need to accelerate.